So hi everyone, thank you for joining us for this introductory video in which we will explain a little bit about the Smart Systems track of the Master's Program in Mechanical Engineering at the University of Turku. So my name is Wallace Moreira Bessa. I'm an Associate Professor in Mechanical Engineering and the head of the Smart Systems Lab.
Hello, my name is Jani Heikkinen. I'm University Lecturer in Smart Systems track. I mainly teach systems modeling and systems engineering as topics.
Hello everyone, my name is Candice Barros and I'm also a University Lecturer with the Smart Systems track, and I am teaching mechatronics, robotics, and hands-on smart systems.
Okay, I'm teaching intelligent control and machine learning for mechanical engineering. And thank you very much for your interest in the Smart Systems track. Let's start by trying to understand what is a smart system. So usually when we think about smart systems, so the first things that come to our minds are autonomous robots and smart assistants. And that's right, because they are indeed smart systems. Because they are able to emulate an intelligent behavior or make decisions. And they are actually able to do that because both of them have sensors so that they are able to feel their surroundings, and also actuators in order to allow them to interact with the environment. So now if we take this as kind of a definition of what a smart system is, then we can say that smart systems are devices that have sensors to allow them to feel their surroundings, actuators to let them interact with the environment, and they're also able to make decisions and emulate an intelligent behavior. So based on this definition, we can expand a bit our view on what smart systems are. And so, of course, industrial robots like industrial manipulators and warehouse robots, they can be considered a smart system. But also our cars are equipped with dozens of sensors. They also have actuators. They also have onboard computing. So they are actually smart systems nowadays as well. And home appliances like this smart washing machine here, they can also be considered a smart system. And also many other devices that were developed and designed to improve our quality of life, like this smart seat, for example, here in the middle, which is able to absorb the vibration coming from the ground so that the comfort of the driver can be improved, and also healthcare devices. So like this artificial pancreas that we have here in the right side. Okay, so smart system then, just to summarize, can be considered devices that have sensors, actuators, and are able to emulate an intelligent behavior.
Okay, so when we combine all of these devices and systems, smart systems, we can also have the applications into modern industry. So smart systems are pretty much transforming the modern industry by integrating these digital technologies, such as data analytics, sensors, artificial intelligence, and other components and actuators from these systems, so that we can also have, other than smart manufacturing, but we can also have this applied to predict maintenance towards the supply chain optimization of the processes. Some of the smart systems in industry are also applied towards the quality control and also for the general energy management and sustainability. So these are areas that modern industry have been focusing on lately, but also we have a couple of smart systems role in modern industry, such as decision making through data handling and also sensor data fusion and towards predictive maintenance. And all of these combined, they can improve the productivity and also reduce the downtime of the operations in industry. Another point that smart systems can add to industry is the safety for workers. When you have systems that are smart and they can also take some decisions, they can also improve the safety around the processes and also improve the quality control. I think that those are the highlights from these systems in industry.
So here's a list of our common and thematic courses. All master's students have common courses like digital factory, 3D printing, additive manufacturing, axiomatic design, knowledge and innovation management, which are kind of courses which will give you a good foundation into continuing to the specialty track of your choice, smart systems. In smart systems, we have only one mandatory course, smart systems engineering, which gives an overview of the different topics which you can then choose for 15 credits from the selection you see in the list. As a selection, there's intelligent control, smart systems modeling, mechatronics, robotics, and out of these you can freely choose your own package, which you see most benefit for your career. Here's a list of master's thesis and free electives. So there's the master's thesis, which is 30 credits, seminar 5 credits, which is basically a presentation and communication about your master's thesis topic, as well as there's a project work worth of 5 credits. Minor studies and thematic studies, which you can choose from a really wide selection of available studies within a university. And as with smart systems, kind of sky's only the limit on the different topics that actually can be useful for you. So we really have a really wide selection for you to do your studies in. There's language studies included, and then there's of course the free electives. So if you couldn't fit like certain smart system studies into the main package, you can take some of them here and add basically any kind of courses that fit to your future career plans.
So we have 2 lab facilities. The first one is dedicated to sensors and monitoring devices and is located in the ICT city. And a second one is a 700 square meters space with a motion capture system where we have a drone arena. We also have mobile robots and robotic manipulators, many controllers and electronic devices, mechanical systems as well, sensors and actuators. So we have 2 fully equipped labs to support not only our courses and the development of master theses, but also our ongoing research projects.
So here we come to an end of this short presentation of our track. So I'd like to invite you to follow us on LinkedIn. And if you have any questions, feel free to email us or reach out to us directly. You can have more information in our website, utu.fi /smartsystems. So there you can find information about ongoing research of each specific areas that we cover, and also get to know our team. And you can also visit our YouTube channel, which is an ongoing project, but we hopefully in the next couple of months we can upload it more often with new content for you guys. Thank you.
So thank you very much. And now I invite you all to watch our promotional video. Okay? And thank you once again for your interest in our Smart Systems track.
Hey everyone, welcome. We're diving into a world that's, well, honestly, it's changing faster than we can keep up with smart systems.
Yeah, and we're not just talking about, the buzzwords here.
Yeah.
We're going right to the source, the University of Turku over in Finland.
Honestly, the more I read about it, the more it feels like we're getting a sneak peek at what's next in tech.
Yeah, for sure. It's cutting-edge stuff.
What really grabbed me is how it's all about getting students ready for, and they actually call it this, the fourth industrial revolution.
Exactly. It's all about giving students the skills they'll need to, well, basically build the future,
Building the future, I like the sound of that. But fourth industrial revolution, that sounds pretty intense.
Right.
What does that even mean, and how does this program at Turku fit into all of that?
Okay, so imagine a world where machines are more than just tools. They're actually problem solvers. The fourth industrial revolution is all about how technologies like AI, artificial intelligence and the Internet of Things are merging the physical and digital worlds. Think self-driving cars that are constantly analyzing traffic in real time, or factories where robots are learning from each other to work more efficiently.
Wow, so in this program, they're actually teaching students how to create that kind of technology.
Yeah, exactly. This program at Turku is all about putting students right there on the front lines of this massive shift in technology.
That's incredible. I was looking at the courses they offer, and two in particular really caught my eye: Digital Factory and Machine Learning for Mechanical Engineering. I mean, seriously, those titles alone sound like something straight out of a sci-fi movie.
Yeah, those are definitely some of the hottest areas in the field right now.
So Digital Factory, does that mean they're literally building things in a virtual world?
It's likely very similar to that, actually. They're probably creating virtual models of entire manufacturing processes so you can design and optimize everything digitally before you even start building anything in the real world.
That's amazing.
And then with machine learning from mechanical engineering, it's all about designing systems that can actually learn from data and make their own decisions.
Wow. So we're talking about robots that can think for themselves.
Sort of, yeah.
What are some of the harder parts of making robots that can learn?
That's a really great question, and it's something that researchers are really digging into. I think one of the biggest challenges is teaching a machine how to deal with the unexpected. Like in a controlled lab environment, it's one thing, but in the real world, there are so many variables, right?
Yeah, that makes sense.
So teaching a machine to analyze all that data, figure out patterns, and then change what it's doing based on all that information, that's incredibly complex.
Yeah, definitely complex. Speaking of complex, I have to ask about the Smart Systems Lab at Turku, this incredible space. I mean, we're talking 700 square meters packed with robotic platforms, tons of sensor technology, and they even have something called an OptiTrack motion capture system.
Yeah, it's really impressive. They've got some top-notch equipment there.
It sounds more like a high-tech research facility than a university lab.
It really shows how serious they are about giving their students hands-on experience. And you're right, the equipment is really state-of-the-art. That OptiTrack system you mentioned that lets you capture really precise movements in 3D, which is essential for things like analyzing how robots move and developing new control systems for them.
That's amazing. And it's not just about having all the cool gadgets, right? They're also sharing that space with the Turku Intelligent Embedded and Robotic Systems Research Group, which is, what, TIERS for short?
Exactly, TIERS.
That means students are working alongside some of the leading researchers in the field, which is an incredible opportunity.
Oh, absolutely. That kind of access is invaluable.
It sounds like they found a really good balance between teaching the theory and giving students the chance to actually apply what they're learning. Speaking of applying what they're learning, I was really intrigued by the program's research projects. I mean, they're working on everything from autonomous robots for environmental monitoring to making intelligent work machines even smarter. They're even involved in something called multi-sensor data fusion for manufacturing. It seems like they're really focused on solving real-world problems.
Absolutely, and that's one of the most exciting things about this field.
Could you tell us a bit more about one of these projects and how it's pushing the boundaries of what smart systems can do?
Sure. Let's take the autonomous robots for environmental monitoring as an example. This project is a perfect example of how smart systems can be used to address some of the most critical challenges we're facing. Imagine robots that can go into dangerous areas, like maybe to collect air and water samples or monitor deforestation. And they can do all of this without putting humans at risk. But it's more than just collecting data. These robots with multi-sensor data fusion can analyze information from multiple sources at the same time, giving us a much more detailed and accurate understanding of really complex environmental issues.
That's incredible. It's amazing to think about how technology can be used to make such a positive impact.
Right.
It sounds like this program is doing an amazing job of preparing students to not only understand the technology behind smart systems, but also to consider the real-world implications of their work.
I think that's a crucial part of what they're doing.
It seems like an incredible opportunity for anyone who's passionate about not just understanding the future of technology, but actually shaping it.
Couldn't agree more.
It's been fascinating to take a deep dive into this program with you.
Yeah, it's a fascinating area.
It really makes you think, if you could design a smart system to solve any problem in the world, what would you choose? That's something for all of us to think about.